Hello, I am Rachana Marathe and I will be taking you through Bressenham's line drawing algorithm examples in this presentation. This presentation is also available in SlideShare. The link is given here. You can follow this link to download the presentation. The aim of this video is to show some solved examples for Bressenham's line drawing which may not be available in regular textbooks. This is the algorithm for Bressenham's line drawing. This algorithm can be found in any standard computer graphics textbook. I have taken the reference from Hearn and Baker. You can see the link to this textbook in the last slide of this presentation. Now let us go to the algorithm and solve an example to find the pixel positions of any given line. So this is the algorithm. What I have done is, we will look at this one example. I have written the algorithm on the left hand side and the solution on the right hand side so that you can compare the algorithm as we solve the problem. Let us look at this example. This is a simple line from starting at x1, y1 equal to 1, 1 up to 5, 3. The two endpoints of the line are 1, 1 and 5, 3. So let's look at the algorithm. First step is to find the dx and dy. Dx is x2 minus x1, that is 5 minus 1, which is equal to 4, and dy is y2 minus y1, in this case 3 minus 1, which is equal to 2. In Bressenhams, we always calculate P0, or it's called the decision parameter, where you will calculate the decision, this parameter, and based on the value of this parameter you take a decision. So that is why this is known as a decision parameter. Decision parameter is 2 dy minus dx, 2 times dy, that is 2 into 2, 4, minus dx is 4. In this case, the decision parameter is 0. As you can see here, the example is if pk is less than 0, then we do a certain x and y and we calculate the next decision parameter. Else, that is if pk is greater than 0, then x and y will be incremented or decremented based on the condition, and we calculate this. Using this formula, we calculate the next decision parameter. But here, since it is 0, let's go with the greater than or equal to 0. Considering it like this, we will go with the else part. So pk greater than 0. In this case, x is k plus 1 and y also k plus 1. So here I have written what is the condition, which condition. Are we taking this condition? Whether this condition is true or this condition is true. Therefore, here, as I told you, depending on the P0, we take a decision and we went to the else part. Pk greater than 0, then xk plus 1, yk plus 1, and the next decision parameter is calculated as pk plus 1 equal to the old pk value plus 2 delta y minus 2 delta x, or 2 dy minus dx. So, since this is xk plus 1 and yk plus 1, the next coordinate that we will plot is after 1 and 1, 1 plus 1, and yk plus 1 will be 1 plus 1. Hence, the new xy that we will plot is 2, 2, and substitute the values here. Pk will be 0 plus 2 delta y, 2 times delta y will be 4 minus 2 delta x. 2 delta x is 2 times 4, 8. So 4 minus 8 will be minus 4. Now we have minus 4, again decision parameter. So based on whether the decision parameter is less than 0 or greater than 0, we go for either the if condition or the else condition. So here, because it is minus, it is less than 0, x is k plus 1 and y remains same. So here 2 will become 3 and y, which is 2, will remain as it is. So the next condition that we will be, next coordinate that we will be plotting is 3, 2. And also we need to calculate the new pk, that is pk plus 1 equal to old pk. Old pk is minus 4 plus 2 delta y. Minus 4 plus 2 delta y. 2 times delta y is 2 times 2, 4. So 4 minus 4 will be 0. So you have seen here first time else condition, because pk greater than or equal to 0. This is what we will consider. And the second condition is pk less than 0, because it is minus 4. If condition, again we are in condition 0. So we will look at it just like this. Pk greater than or equal to 0. Then xk plus 1 and y k plus 1. So the next coordinate will be 3 plus 1 and 2 plus 1. And therefore 3 becomes 4. After 2, 2 plus 1, it becomes 3. The next pk that we will calculate is based on this equation. But we stop here to check whether we have reached the last point of the line. No, they are not equal. We have reached 4, 3, whereas the end point of the line is 5, 3. Hence we need to calculate the pk plus 1 again using this equation, old pk value plus 2 dy minus 2 dx, which is minus 4. Again minus 4, which is less than 0. Therefore we go for the if condition, xk plus 1 yk. So xk plus 1, 4 becomes 4 plus 1, 5, and yk, y remains the same. So 3 is same here, 5, 3. And the next decision parameter will be calculated as pk plus 1 equal to pk, old pk plus 2 dy. Old pk will be minus 4. Here I have not calculated this because when we compare the latest xy coordinate, it is matching with the end point of the line. Hence we stop here, and the pixels are, we start at 1, 1, like in our example the starting point is 1, 1, and then we have calculated 2, 2, 3, 2, 4, 3, 2, 2, 3, 2, 4, 3, ending with the last point or the other end point of the line. So this is one example for Bressenham's line drawing. Let us look at another example, example 2, where the line, first point of the line is 2, 3, and x2, y2, the end point of the line is 7, 7. Here also similarly I have kept the algorithm on the left hand side and the solution on the right hand side. You can compare parallelly as you solve the line. Let's look at the first one. As we know, x1, y1, 2, 3, x2, y2, 7, 7. dx is x2 minus x1 and dy is y2 minus y1, 5 and 4. The first decision parameter that we are calculating is 2 dy minus dx, which is 2 into 4 minus 5, which is 3. And you can see here 3 is greater than 0. 3 is greater than 0. Hence x is plus 1, y also plus 1. 2, 3 become 3, 4. And pk plus 1 equal to pk plus 2 dy minus 2 dx. And our old pk is 3 plus 2 delta y is 8 minus 2 delta x is 10, which is 1. Again 1 greater than 0, therefore again else condition, x increment, y increment, therefore 3, 4 becomes 4, 5. And we use this equation to calculate the pk. pk results in minus 1, or decision parameter results in minus 1 which is less than 0, if condition. So we go to the if condition. Here in the if condition, only x increment, y does not increment. So 4 comma 5 becomes 5 comma 5, and the pk plus 1 is calculated using this formula, pk, old pk, that is minus 1 plus 2 dy. 2 dy is 8. So minus 1 plus 8 giving us 7. 7 is greater than 0, therefore else condition. In the else condition, we know x increment by 1, y also increment by 1. Therefore 5 5 became 6 6, and this is the equation for the decision parameter pk. And the decision parameter is 5, which is again greater than 0. Therefore again it is else condition, x increment by 1, y increment by 1, and the new decision parameter equal to old decision parameter plus 2 delta y minus 2 delta x. So 6 6, because it is plus 1 and yk plus 1 is now 7 comma 7. I have not calculated the decision parameter as we have reached the end point, other end point of the line. So it is easily, you can easily collaborate with whether it will be if condition or else condition, as I have mentioned here, for each iteration. And at the end, let us just look at the pixels. We started at 2 comma 3 and 3 4, 4 comma 5, 5 comma 5, 6 comma 6, and 7 comma 7. So these are the pixels that we will be plotting to reach from a line from 2 comma 3 up to 7 comma 7. This is the reference for the Hearn and Baker for the algorithm. It is open source. It is an e-textbook. You can check for the algorithm from this reference.